executive roles. Ladies and gentlemen, please give a warm welcome to our esteemed speaker, Dr. Richie Etwaru. With over 20 years of experience in executive roles and entrepreneurship, Dr. Etwaru brings a wealth of knowledge on turnarounds and transformations. As the Chief AI Officer at Mobius, he integrates strategy, leadership, and cutting edge technologies to drive sustainable growth. His breakthrough inventions in spatial computing and data privacy have reshaped the AR, VR, and XR marketplace. As a renowned author, TED speaker, and keynote presenter, Dr. Etwaru's influence promotes trust, kindness, and fairness in commerce. Let's hear his insights today.
Good morning, everyone. If someone can confirm for me that you can hear me, I'm ready to get started. First of all, thanks for having me. I really appreciate the opportunity to address Guyanese. I'm from Guyana. I was born in Berbice, in a sugar estate town named Blairmont. What I'm hoping to share with you today is a view of what artificial intelligence can be above and beyond large language models. And in addition to that, to give you a sense of my vantage point around what it will impact in the future, and more importantly, what that may mean for Guyana and for Guyanese. So with that said, I'll go ahead and share my screen and walk you through very quickly a demo of an application of technology that I invented and a company that I manage, and then walk you through some of my remarks. I'm going to go ahead and share my screen, and thank you for confirming that you can hear me. If it is okay, could you also go ahead and confirm that you can see my screen right now? I'll switch back over here very quickly to see the comments. Can you see my screen? Fantastic. Excellent. So what you're looking at here is you're looking at an application of machine learning and computer vision. Just for some housekeeping, computer vision is a subset of artificial intelligence built on a whole different set of models and is a part of all the other aspects of AI. What I'm going to demonstrate is a version of spatial computing that does not require any hardware. Meaning, if you think about a VR headset or an AR experience, if you put on some hardware on your body, you'll be able to get a perception of depth and feel some sort of spatial experience. That requires that you put some sort of hardware on your computer and some sort of hardware on your body. I don't have any additional hardware on my computer. I don't have any additional hardware on my body. And I'll demonstrate to you spatial computing here, which was invented by a Guyanese using artificial intelligence. So first things first, this is a 3D room. I will turn on a feature here. And what you'll notice is that as I move my head around, this room starts to engage with me. Now you are seeing my reflection. So you're not feeling what I'm feeling, but I'm feeling a perception of depth. As I lean in, it feels like I'm flying into the room. As I lean out, it feels like I'm moving away from the room. And as I look around, you'll notice that the room is responding to my face. This is machine learning that was trained to understand the human face and to be able to then adapt the screen to where my face is relative to the camera that's in front of me using computer vision. Of course, if we're able to train machine learning to understand our face and our viewing intention, we can also train it to understand our interactive intention. So these puppies come alive. You'll see here that we've been able to get really good precision on the hand to be able to use the pinch control to do different types of things. That was drawn into the depth. These puppies come alive as well. So this is using all artificial intelligence, machine learning, and computer vision to be able to achieve spatial computing without any hardware. Let me show you a couple of quick applications of this so you'll get a point of view. Imagine you're doing a presentation in the future, and I should have probably done this here, but you guys would have gotten too much of the movement. You can see that the air in front of my computer has been mapped to the various slides that are in front of me. And I'm just going to grab one of these slides like this and pull it forward to be able to present. I can put my hands up. I can circle, works on everything, everywhere. I can point, put my hands to the side of the screen and just swipe it to change the slide, or grab the slide and push it back that way. This works on anything. So it works on Mac, it works on PC. This works on a television if you put a camera to it. Works on the web, builds applications. Very easy to build applications. We'll be releasing this out to the public. You can see that my hands are engaging with controls here. I can take a control and move it over. You'll see that blue dot move to the other side. Or I can do things like this, move this forward, or change the color of this over here. So that's a little bit of a demonstration of artificial intelligence. It is spatial computing without any hardware, using machine learning and computer vision. With that said, what I'd like to do next is to switch to PowerPoint and to show you a set of slides that give you a sense as to where I think technology might be going and what that may mean for the various regions of the world. I'm switching to PowerPoint. So this talk I call the Atlas of Artificial Intelligence. Okay, excellent. Awesome. So the Atlas of AI. I want to walk you through something that will kind of give you a point of view as to where we are, what may happen, and how you can take advantage of what's going to happen through this economy. First things first, I want to make sure I settle all of the opinions that's in the marketplace. With any human change, whether it's changing what movie you're going to go see, or changing the strategy of a company, or even changing the long-term vision for a country, when things change, humans tend to have different opinions about change. And with AI, there's no different. As you'll notice with AI, there are evangelists for AI, and there are also alarmists for AI. And like every other change, our opinions are on a bell curve. There are the pessimists, there are the realists, and there are the optimists, and that bell curve kind of behaves this way. Now, what's unique about AI is that there's an expertise paradox. The experts that understand AI see both the alarmist and the evangelist point of view at the same time. It's almost like on one side of this, if you're an expert, you can look at it and say, I wonder what AI can do. But at the same time, we also think, I don't know what it's going to do. And this expertise paradox is what tells us that this is a technology of consequence. Every time you see experts that see both sides of this, for example, with nuclear fission, it tells you that this is something great, this is something fundamental, and it's going to have impact. Now, it's going to take some time to figure out where we go. On one side of this, there's Ray Kurzweil that believes that the species is going to go through some sort of continuance. We're going to continue. We're going to transcend from an organic species to some sort of hybrid species that has some digital to it. And on the other side of that is Mustafa Sullivan, who says, we're going to have to contain this technology. We're going to have to figure out how do we absorb it into society and figure out ethics and responsibility and trust and all the other things. So if you're a programmer or you're a large organization, as it sits today, you're facing this massive bias for action while still having a significant amount of anxiety around that action, because you're left having to figure out which side of this is really going to be the future. Now, I believe that we are going to remove that fear and we're going to advance forward. And I believe so because I look at the problem that everyone describes with AI, and everyone says AI is a black box. And as a result, we don't understand what it is. I believe that that is different. A neural network is not a black box. As a matter of fact, the name of this phenomena of a black box is wrong. Black boxes are some things that are on airplanes that you can't look into. As a matter of fact, you're not supposed to look into it. A neural network, you can look into it. You can look into it as much as you want. The problem with looking into a neural network is we don't have the faculties to understand the complexity of what's going on in a neural network. We don't have the visualization capacity to represent what's going on in a neural network. So even if we could represent it, we wouldn't be able to understand what we are seeing. I believe that that's a problem that we can solve. And when we solve it, we're not going to have to choose whether we're going to continue in some new species, or we have to contain this really dangerous technology, we're going to realize that we can continue from one place that we are to another. Now, let me take a quick moment here to give you a visual of how neural networks operate so that you too may start to realize that it's not a black box, but instead it's a glass cube. A neural network can be visualized the following way. Imagine that as you go from the input to output and you go through the hidden layers in the middle of a neural network, think of layer one as a wafer with a lot of different holes in that wafer. There are big holes, there are small holes, and those represent the parameters and the weightings of what's going on there. And depending on the depth of the neural network, there's a lot of wafers like that, many of them, all with different sizes of holes. And as data passes through that neural network, based on the other data that it's being passed with, it kind of chooses its unique combination of how it goes from one side to the other. And even in back propagation, it goes the same way. And depending on what data you move through, it may go through that neural network in different ways. There's no magic about it. It's math and statistical probability. Now, we can't visualize that. It looks like a spaghetti of different lines. And so we're afraid of it because we can't understand it. It's almost as if you want to understand a neural network, try dropping a marble in this image that you see here and trying to figure out where that marble arrives on the other side. I believe that this is simply a display problem. And I also believe that we will be able to solve this display problem because we will go from what was once a black box to now a glass cube. And as we see it and we understand it, we'll get to the equivalent of things like a FICO score. Here in the US, we have something called a FICO score. I'm not sure what it is in Guyana, that tells you how dangerous is an AI network, how dangerous is a model for you. We may even get to a red, yellow, green. You know, green being it's good for humanity, it's trustworthy, it's safe. Yellow might mean watch out, not necessarily sure whether that model is going to be manipulative or not. And red might mean that's not a good model. Don't engage with it. But we will get there. We will get to something like a FICO score for every model, and that will advance us forward. Now, I believe that we will sit right here in the middle where two intelligences coexist in harmony. Now, assuming that that is the outcome, and we're not going to go over here, and we're not going to go over here either, then the question is, how big is it, and what might happen so that we can plan as individuals, as organizations, as countries, as cultures, as regions, as a planet, even intergalactically. So to size it, let's think about the impact of other technologies to the world. Maybe software was about this size. Maybe electronics was about this side. Maybe industry, our capacity to be able to build commerce through cash flows, it impacted society by this size. Maybe education was really impactful for society. Cooperation, our ability to actually pool our resources and achieve greatness. And then language fundamentally changed humanity. AI, I believe, is about this size. What is unique about AI is it does something really interesting that not many of these other inventions before did. And that's why it's so implicative. AI takes everything that has come before it and it amplifies it and makes it a little bit better. It makes software engineering a little bit better. It makes electronics a little bit better. It makes industry a little bit better. It takes math and makes it better. It also changed our ability to cooperate differently. If we were to automate all of society and we were to bake intelligence into everything that we do, cooperation is going to go from competition to trust. And as we saw over the last couple of years, it took language and changed this massively and fundamentally with the implications of large language models. And so that's what's unique about this technology, that it takes everything that has come before it and it amplifies its impact on what we do, how we live, how we play, how we make money, how we get entertained. So if AI is going to be that big, how far back does it go? I believe that AI applied at the platform of biology can take us to a place, especially with synthetic biology, can take us to a place where the impact to our species is so fundamental as the moment that we got up from 4 onto 2. Now, that is hundreds of years out, maybe even thousands of years out. And when we look back at it, who knows what it will be? What I can say is that if we understand the size and we believe we're going to go right down the middle and not on the 2 edges, then what are some of the things that are going to change? And what does that mean to us? Well, one of the things that is going to change is how we learn. Learning is going to change fundamentally. Not just how we learn as children or how we learn as individuals, but how we learn as organizations, how we learn as cultures. We just saw search and find, which is something that we had forever or almost forever get disrupted. Since the invention of language and things like books and the printing press, we had this capacity to search and find. Even librarians search and find. Google, search and find. Inquisition in, information out. We just went from search and find to something completely different, which is inspiration in and insight out. That's the difference between a Google search and a large language model prompt. And so learning is going to change fundamentally. And what's unique about this is that when things that are this big changed before, some countries get it on day 1 or day 0, and other regions of the world, you could wait 20, 30, 40 years before you get it. I grew up in a part of Ghana where electricity was not available for almost 30 years after it was available in Europe and North America. With AI, everyone's on day 0. And so this is something where the education system could change, upskilling could change. And for Guyana, that's really important right now. The other thing that's going to change is liability. Who is accountable when an algorithm makes an error? To err is to human and to forgive is for human. But when an algorithm drives an autonomous car and knocks over someone, what does that liability look like? What does the liability look like when a government purchases a model from a large organization that operates in a different country with a different jurisdiction of law, and that model impacts its citizens in a negative way? What does it look like when an organization's corporate veil could be pierced because a model was not protected in the insurance that it has? And so these are the types of things that are going to change fundamentally. Data can be flawed. Training can be flawed. The application of models could be flawed, which is going to change liability significantly. Labor is going to change fundamentally. Now, I don't believe that this will capitalize our ability to create or generate life. I don't think we need to go to universal basic income. I certainly believe that we will have to go to universal basic intelligence, which will be equivalent to universal basic education or universal basic healthcare. But what we do, how we do it, why we do it, how long we do it, and what we get paid to do is going to change. The fundamental change that I believe is going to happen here is we're going to go from knowledge workers, which is what changed when we went from industry to information, to what I call visionary workers as we go from information to imagination. Visionary workers are not going to be based on the exchange of information, but it's going to be based on the exchange of ideas, because we're going to commoditize and automate so much that information sharing is going to be a commodity, and we'll be able to envision things that we can build faster, test faster, commercialize faster. Of course, laws are going to change. I'm going to skip over this because I'm sure everybody understands this part about whether you're going to build the language in the government set to be able to prosecute deep fakes and the impact that come with it. And of course, love's going to change, whether it's for connection or to solve for loneliness. And we've seen some of this happen before. So with all this change in front of us and looking at this atlas that has implications that are so far back and implications that could be so fundamental in the future, we have to have a mechanism to be able to navigate this. How do you navigate such complexity of a technology that's moving exponentially and pulling everything before it in a fundamental way? I've established this compass to give everyone an understanding, or at least a way to navigate the complexity. Think about the north of the compass having the benefit of people at the top, the south having the management of power. Big technologies like these, they shift power. On the east, the nation state. What are the benefits to government? And on the west, the tech state. What's the benefit to industry? These are the things that's going to happen. Up here, it's no question that the nation state will regulate AI in the interest of people. We're going to do that. Every time we find something that threatens us, we regulate it down to a place that it doesn't. But at the same time, the nation state is also going to participate in a geopolitical arms race around AI. So as much as we want to control it for the benefit of our people, we're going to want to leverage it for power. On the tech state side, we know that technology is going to be used to significantly improve the standard of living, just like computers did, automation did, information did, the printing press did. But we also know that technology is going to be used to significantly increase surveillance capitalism. So as you think about what's going to happen in the context of those 5 things that I laid out, you want to look at it from this framework and try to parse fact from fiction. Try to parse what's important to me today and what may be important to me tomorrow. Now, as we think about today, the lens of today is that post-COVID, we're looking at the global risk in the system. Risk not in that something bad is going to happen to us, but risk that comes from the uncertainty of not knowing how we're going to get back to normal and what the new normal might look like. You're also seeing interest rates in some of the geographies of the world move in an unprecedented way that's impacting economies globally. And last but not least, as I mentioned before, you're seeing an arms race that is happening at the same time. And so as you go through these 5 things, you ought to use that compass to understand, what does learning mean to people? What does learning mean to power? What will be the variance for those that have universal basic intelligence from those don't, and how fast they might learn and how well they may do in exams compared to those who don't? You ought to think about liability. What are the countries that are going to make laws that are friendly to commerce, but at the same time, the most responsible to AI? And what is that going to mean to the flow of capital to those geographies that have more attractive sovereign offers for companies? Labor, same thing. Laws, same thing. And of course, love, look at it from the compass of those lenses. And so as we sit here and we start to think, and this is my last slide, as we start to think about all of that information that we just consumed, how does it change? What do we do? From an organization's perspective, every aspect of the 21st century has been changed because we manage somehow the propensity to win as an organization with the capacity for changing at the same time. And it's mostly a zero-sum game. Those who overinvest in winning don't seem to have the capacity to change. Those that overinvest in changing lose the capacity to win. And this is that slider that we kind of go back and forth with as an organization. AI and its implications and the speed at which those implications are going to happen is going to force the organization and countries and governments and schools and hospitals to move from an organizational structure to something that's a little bit more dynamic, something that's more like an organism, something that has the ability to repeatedly and abundantly reinvest itself within a set of organizing principles. And this is what I believe the 21st century economy is going to look like across all segments and sectors of economy. Just like we have transformations today that take about 3 to 5 years to do and have strategies that are adjust quarterly, we're going to move to a state of constant adaptation because the technology is moving so fast. The model diaspora is moving so fast. We're activating data that we've never used before, that's been sitting in databases for almost decades in ways that are completely new. This is going to require that you have different talent, different capacity for risk or optionality for risk, and a completely different mindset about what the speed of the future is today. This concludes my remarks. This is what I believe is the atlas of artificial intelligence. I thank you for your time, And I wish you a fantastic conference ahead.